So this particular Python code I have written to showcase how we can impute missing data using those three different techniques. So I'm just trying to explain what I have written and what is there. Like, as you can see, there is a pandas package which I have written as PD as an alias, and I'm writing using pd dot read underscore csv function to import the data in my Python file, right? And this is some COVID data. The COVID word is very known to you. So if I just run this cell, and what I have written, I have just printed first few rows of the data, not the full data set, because that is not important. So if I just run this, okay, just a minute, there is some issue here. Okay, just a minute. Maybe just a minute. Missing value imputation. Okay, just a minute. Data is not present. Okay, just a minute. To the কোথায় গেল ডেটাটা, কোথায় গেল কোভিড ডেটা? ওকে, সরি, কোভিড ডেটা। Okay, so there was some issue in the data was not found anyway, so I have kept the data in the same folder now. If I now run this, I hope, yeah, it's came. So as you can see, there are a lot of features present in the data set, right? Maybe all the features is not important for me. Anyway, I'm not going to create any machine learning model right now. My intention is to show you how we can impute missing value using those three techniques. And what are the missing values? You can easily understand. That is what is present in NaN. This NaN means not a number. Okay, that means there is something missing here. That's why it is representing NaN. So as you can see here, that there are few, if you see, there are a lot of columns or features, you can say, where this NaN is very frequently occurred, right? Something like this. So that's why just I'm showing you that, for example, this extreme poverty feature is present here, you see, where all the row has missing value. This particular feature is not going to contribute anything for designing my machine learning model naturally, because for all the data it's unknown, it's missing. So what I can do, I can simply omit this particular feature from my data set. How we can do that? We can use by this particular comment. What I've written temp equal to covid.drop. So this covid is my data frame name, as you can see here. So covid.drop, so there is a function, drop function of a data frame, to drop a particular column or maybe set of columns, not only one but more than one columns. You have to just write the column name by comma within this bracket. So in this drop function, we pass a list of columns. Here I want to drop only extreme poverty, so that's why it is basically a list of only one column. That's all. If you want to pass more, if you want to drop more than one columns, you just have to write a comma and maybe some another column name you have to write, something like this. Anyway, so I'm not writing anything here. And now if I just run this code, you will see that extreme poverty column has been dropped because you will see that here total number of column was 40, and now here the total number of column is 39. So definitely the extreme probability column is gone. In the same way, there is a situation, you see that, say for example, also there is a possibility that I want to drop, say, those particular rows whose ISO code is ABW. Why I am saying doing this? Because maybe for all the data of ISO code ABW, lot of features are missing. For example, you see lot of features are missing, right? Lot of features are missing. So maybe it is not going to contribute much in my designing a model. Even not even contribute, but also maybe it will basically harm you to create a good model. So you can try to delete those data which are coming from ABW ISO code. How we can do that? Here also we can apply a drop function where it's like something like, you see I have written that you drop this where this temp of ISO code is equal to ABW. That's all. Okay, so if I just run this, you will see. Okay, sorry, just a minute. It should be temp equal to. You must write temp equal to. Then only it will be deleted. You see. So the ABW has been deleted. That's why ABW is not coming as the first 5 rows. Anyway, let's go further. In this way, basically, okay, by the way, here I have written one thing, that actually what I tried to show you here, that if you write this line, it is not deleting this ABW, right? Why it is not deleting? Because you have not stored into some variable, I mean some data frame, maybe the same data frame or maybe something else. So the actual thing should be that I have written here. That is actually I wrote previously. The temp equal to something like this. So then only you will see the ABW has been deleted. Fine. Now one thing, that the index of ABW was 0, 1, 2, 3, 4 and maybe many more. Since ABW row, the row having ABW as ISO code has been deleted. That's why their corresponding index is also not available. You see here the index started from 160. Why? It always should start from 0, right? Because once you will delete a set of rows from a data set, it's not possible to remember or keep track that which particular indexes become missing. So if you delete some set of rows from your data set, that row will be deleted, but the index always should start from 0 to n minus 1 in this form. But it is not happening here in this case. To do this, what we do, we write a special parameter that is in place equal to true. This particular thing was not present in my previous, if you see, it was not present in my previous uh, line. Now I have just written this one, and because of this, if you just run the code, you will see, I'm sorry, still again is not showing because I have to store it here and then I can show it. Sorry, what happens? Not read head. Okay, maybe. mm, okay, let's do one thing. Let's try here. Just trying to follow the same thing. 012, and then I'm writing this one. No, I'm having some issue here. Anyway, so we don't have much time to go through the reason of this. So I will see this and I will tell you later what is the reason for I have to see what exactly is happening here. Anyway, so let's continue further. The next, which one, which is very vital now, that is the last point that we have seen, that if the missing value is in random order, then we can go for either mean or median or mode, these three technique to impute those missing parts. And that is what the code of this. So it's very easy actually. Like, to do this you have to use this particular package sklearn.impute, and within this package there is a specific function that is called simple imputer. Okay, so what I have done here, you see that I have used this simple imputer function, and within this simple imputer function you have to specify which strategy you are going to use. Is it by mean, or is it by median, or is it by mode? And accordingly the missing value will be imputed automatically by mean, median or mode. For example, here this, for this particular cell I have given strategy equal to mean. Next I have written strategy equal to median, and next here I have written strategy equal to most frequent. Remember, mode always represents the most frequent number happens in a data set, right? So that's why it's not mode, it's written as most frequent. Now, after initializing this simple imputer, remember, it is basically creating something like an object. Mean imputer is an object of simple imputer class whose strategy is mean, which is going to be impute in mean using mean. Now, using this object mean underscore imputer, we have to call a function that is fit transform. So the object name dot fit transform, and within this you have to pass this data frame. Say for example, the total case was a feature in my dataset, and that I want to impute based on this mean. And if I do this, you will see that the total cases feature that we had, the parts where I have not a number, like you will see this total cases has not a number in the second row, fourth and fifth row. For the first 5 rows, second, fourth and fifth, maybe other rows are also missing. If you print the full data set, maybe you will see many other, in case of many other rows also it's missing. However, just for 5 row, if we consider, the second, fourth and fifth is missing. If you come here, you will see that second, fourth and fifth has been replaced by some value. And what is this value? This value is the mean of the distribution of the total cases in the whole dataset. So there are a lot of total cases data present for different ISO codes and continent and region are like this. Say for example, total number of row in this data set is say 1000. So among 1000 rows, maybe 200 rows are missing. 800 row has some value. For this total cases feature only I am saying. This 800 value of this total cases feature creates a distribution, and in this distribution it must have some mean, right? And that mean is this 70,687.083292, and that's actually automatically replaced wherever you have missing value in this particular column. In the same way, you can do by median as well. But remember, the code has not been changed. The strategy name is changed only. So it's not like you have to remember a lot for each and every cases. You just can trying to understand. You can have a practice a little, and you can easily be habituated with this. So if I just for example, if I run this code, you see instead of median, the data has been changed. You see, it's become 696 in all the cases where it is none. It was none previously. Now, it's not possible to evaluate right now that putting median in the missing value part is better than putting mean in the missing value part. That is part of investigation. We have to check if we replace the missing value by median and feed the data into the some model, how good the model is created, that we have to check for different cases, and then only we can conclude that maybe putting missing value by median is a better one than putting missing value by other strategies. You cannot say that always for any data set putting some particular strategy is the best one. It varies, depends on the data set to data set, problem to problem, it definitely varies. So it's always part of a research. Anyway, in the same way, I hope you can understand, it can be easy for by the most frequent also, and you see for the most frequent it becomes 0. So which one is going to be the best representation, that is not possible to understand right now. But these are the basic three technique by which you can replace the missing values. At least this is what we can understand from this point. So this is all about putting the missing value for the data processing task. Now let's do one thing. Let's go back to the to the other data processing task again, and let's continue with those.